Okay, everybody, this is the last lesson for Chapter 8. This is the z-test for a proportion. For those of you that are doing a project where you found a certain percent, for example, if you had something like 25% of the football players have one concussion in their life, that would be this is the test you're going to use to compare your data to that percent. Okay, so z-test for a proportion. Again, I've pre-written these notes, so you can pause this at any time. Again, recall with me what a proportion is. It's that percent of the population. That's what the proportion is. So if I said 51% of Americans buy generic products, or 35% of students go out to dinner once a week, that's the percent of the population. So again, if you're thinking about your research project question, okay, maybe you found something about like, 29% of the students right now have Supreme stickers on their car. I don't know. I'm just going there. But you just figure out something, okay? And then this is the test you would use to compare that to. And if you find that, by the way, somewhere online, you need to put that in your report. Make sure you include that web address. All right, the test statistic formula that we're going to use, a little different. It's not x bar minus mu over standard deviation, et cetera. It's z equals p hat minus p over the square root of p times q divided by n. This whole thing underneath is square root. Okay, now let's go over what these are. Okay, what's p hat again? Well, p hat is your sample proportion. Okay, your sample proportion. It's your x divided by n for your sample. Okay, out of 50 kids, 13 of them said they like chocolate milk. Okay, something like that. So that's 13 out of 50, x over n. P, this p without the little hat on it, is the population proportion. Okay. Q, now we all know how to find Q. Q is the 1 minus P. 1 minus P. And then N, that's obviously your sample size. Okay, sample size. All right, so now these are the assumptions for testing a proportion. The sample number 1 has to be random. We know that. The conditions for a binomial experiment are satisfied. If you go back to when we did binomial experiment in Chapter 5, you can read those conditions. And then this might be different and new for you, but your sample size times P, your population proportion, has to be greater than or equal to 5. And then your N times Q has to be also greater than or equal to 5. So more than likely it should be, but you can always just double check this. All right, you should have downloaded this examples for z-test for proportion 8.4 on LMS. We're going to do these 3 examples, and then you're going to work the homework by yourself. So number 1, a researcher claims that based on the information obtained from the Centers of Disease Control and Prevention, that 17% of young people ages 2 through 19 are obese. To test this claim, she selected 200 people from ages 2 through 19 and found that 42 of them were obese. At the significance level of 0.05, is there enough evidence to reject this claim? So again, think of you as being the researcher here. You go out and you find 200 people. So 200 must be your N. Okay. Ages 2 through 19. Is that something that we're going to put down here? No. Okay. That's just some information about this study. 17% of the young people were obese. Okay. So what is that 17%? Well, that is our P, not P hat. That is our P. That is 17%, 0.17. Okay. Out of those 200, 42 were obese. What's that 42? Well, that's our X. 42. At the significance level of 0.05. Is there enough evidence to reject the claim? Okay, so now we are going to go through each of these steps right now. We're going to do all 5 steps again. So step number 1, you have to state your HO and HA. Your HO would be, well, we don't want to write it that way. Your HO, no longer do you write mu, because we're not talking about a mean. We're talking about a proportion. So our parameter is going to be the proportion, the P. So our HO would be that P equals 17%, that my population, even in my sample that I got, is going to be about 17%. Well, the alternate, let's see what she wants. To test the claim, she randomly selected and found that they were obese. Is there enough evidence to reject the claim? Am I looking to see if it's greater than or less than, or am I looking to see if there's a difference? Well, there's nothing about greater than or less than, so it's more than likely just checking to see if it's different than 0.17. Okay. Step number 2, you state your significance level. My significance level is alpha is 0.05. Okay. So again, what does that mean in terms of our distribution here? That means if I have a two-tailed test, two-tailed because it's not equal, I want this and this together to be 0.05. Well, that means that this must be 0.025 and this must be 0.025. So how do I find out what that Z is? That's right, I use inverse norm, and you do 0.02501. And if you punch that into your calculator, you get about negative 1.96. So this would be negative 1.96. So our critical value is plus or minus 1.96. Negative being here, positive being right there. Okay, so step number 1, write your hypotheses. Step number 2, state your significance level and the critical value. Step number 3, now you are going to do your Z test statistic for this proportion. And again, the formula is P hat minus P over the square root of PQ over N. So let's put some things in here. P hat, well, P hat is based off of our sample proportion. So again, out of 200 people, 42 were obese. So P hat is 42 out of 100, which is just 0.42. So 0.4. Actually, I did that wrong. It's not 0.42. It's not out of 100. It's out of 200. Excuse me. That's 2.1. Must have set up 2.1. There we go. Okay, 0.21. Minus P. This is the population. 0.17. Divided by the square root. P, 0.17. Q. What's the Q? Well, about 0.83. Remember, these two together make 100% or make one whole. And then divide by your N, which your N is 200. Okay? Now, real quick, you really don't need to kind of figure this out. You could, but your calculator is going to give you this information in a moment. I'm going to show you how to do that. Whenever you're doing a Z-test for proportion, you go to Stat, Test, 1-prop Z-test, not interval, Z-test. Okay, so go to Stat, Test, 1-prop Z-test, which is number 5. We're not doing intervals, we're doing Z-test. We're going to type in our population proportion, which in this case is 0.17. 0.17. Our X was 42. Our N was 200, so that stays the same. We are going to choose the not equals to, and we're going to hit calculate. And look right there, Z is 1.51. If you work this out, this would be 1.51. Okay. Your P is 0.13. Your P hat is 0.21. Now, here's where it could get confusing. Please listen to me. You have a P, you have for a population proportion, you have a P hat, and then you have this P value, okay? That P value is whether or not we reject the hypothesis. This right here underneath the Z, that is your P value. You need to write that down in step number 4. Your P value is 0.132, okay? 0.132. Is that greater than, less than, which one to compare to 0.05? Well, 0.13 is greater than 0.05. So do we reject or do we not reject? Well, you only reject the HO if it's low. This is not low, so we do not reject the HO. So then step number 5, I'm going to have to squeeze it right here, is if we do not reject the HO, then there's not enough evidence. There is not enough evidence to reject the claim. That 17% of young people are obese. So everything is the same except we've got a new formula, okay? And we've got a new parameter here. We put P because we're talking about a percent, okay? A percent. P equals 0.17. P does not equal 0.17, or it could be P is less than 0.17, whatever. You still write your significance level. You still find that critical value, okay? Your Z is now the new formula. Just be careful you know what you're talking about. P hat is from your sample. That's your sample. P is the proportion from the population. And then type this all in, and then this P, I wish they had a different symbol for it. Maybe you could just make up your own, but this P is the P value that we compare to this significance level. Okay, that determines if we reject or do not reject. All right, let's do another one, and you can try one on your own. So, cesarean babies, a report stated that 21% of babies are delivered by cesarean section. A researcher believes that this percentage is less than 21% in a large hospital. He randomly selected 50 newborn infants and found that 8 were born by cesarean. At the 0.01, is there enough evidence to support his claim? Okay, so here we go again. Let's kind of talk about what these numbers are. 21%, that is my population proportion, 0.21. Okay. What else do we? He randomly selects 50 newborn infants. That's my N. And found that 8 of them were born by cesarean. Okay, so that's my X. So then my P hat is X over N. 8 out of 50, which, what's 8 divided by 50? 0.16. Sorry, you can't see that. There we go. All right, what else do I need here? At the alpha being 0.01 significance level, is there enough evidence? All right, so let's go through our 5 steps. Step number 1, what's my HO? What's my HA? My HO is that P equals 0.21. That is the population's proportion for cesarean delivery sections. But this researcher thinks it's less than 0.21. So if I'm drawing this, this would be a one-sided left or right. If I'm less than, it'd be left. He thinks this is .01. Okay, so number 2, my significance level, alpha equals 0.01. How do I find my critical value? Inverse norm, 0.01. And you'll get, let's see, inverse norm 0.01. Come on. Negative 2.33. Negative 2.33. Step number 3, let's plug in our z. P hat minus P over square root of PQ divided by N. P hat, 0.16. See, I like having everything written over here. Kind of helps me out. Minus your population, 0.21. Divided by square root of your P, which is 0.21, times your Z, which is 0.79, divided by 50. Okay? Put that in your calculator. You're going to get roughly negative 0.86. We can check that in a minute on our calculator. When I go to stat, test, one prop Z test, I'm going to type in my information. My population proportion is 0.21. My X is 8. My N is 50. I'm going to choose less than. Calculate. Look at that. My Z was 0.86, negative 0.86. My P value, this is what step 4 is, 0.19. P equals 0.19. Is that greater than, less than my significance level? That is way greater. 0.19 is way bigger than 0.01. So do not reject. You only reject if it's low. So step number 5, there is not enough evidence to support the claim that there is less than. Actually, I think that it's quite more than. I think there are way more cesarean births. That might be a topic that you might want to do and research yourself. All right, you can pause this video right now and try example number 3, but I'm going to just finish it for you. If you want to keep watching, if you feel like you're good about it, you can stop it right here, but I'm just going to do this last example real quick. An attorney claims that more than 25% of all lawyers advertise. A random sample of 200 lawyers in a certain city showed that 63 had used some form of advertising. At the 0.05 significance level, is there enough evidence to support the attorney claim? Use the p-value method, which is mainly what we use. Okay, so let me write down some things I know. This is my P, 0.25. He sampled 200, so that is my N. 63 had used some, so that is the X. Might as well do P hat right now. 63 divided by 200, which is 30 something. 31.5. So 0.315. And alpha is 0.05. Okay, so step number 1, HO, HA. I think my HO, my population is 0.25. My alternate is there enough evidence to support the claim that more than 25% of all lawyers advertise? Okay, so more than 0.25. Step number 2, my significance level is 0.05. That's my alpha. Oops. My critical value. So again, if I'm drawing my little thing here, I want this to be 0.05. When I type it into inverse norm, I don't type 0.05. Remember that. I type 0.95. Got to go to the left side. And I get 1.64. So that's my critical value, 1.64. Step number 3, let's actually find our Z. Z equals P hat minus P over the square root of PQ divided by N. So 0.315 minus 0.25 divided by the square root of 0.25. Q would be 0.75 then, divided by 200. You type that into your calculator. You should get roughly about 2.12. I mean, look at that number. Aren't you already in the critical region? If 1.64 is your cutoff and you're at 2.12, you know what's going to happen right now. Let's find out what our p-value is. So stat 1 prop z. Let's type in my information here. 0.25. X is 63. N is 200. I'm looking for more than. I got a P of 0.016 or 0.02, which is less than my significance. Okay, just again to highlight. So if the P is low, reject the HO. So number 5, if you reject, then there is enough information. There is enough evidence to support the claim that more than 25% of lawyers use advertising. Well, we know that. I have seen so many lawyer advertisement commercials. All right. Hopefully this made sense to you. Take a picture of your homework and email it to me. Bye.